Hello everyone and welcome to Roadmap. So today's topic is acid, bases and salts part 1, and if you like the video don't forget to click on thumbs up button below. You can also subscribe for more video updates. Now topics to be covered are introduction, chemical properties of acids and bases, reaction of acids and bases with metals, how metal carbonates and hydrogen carbonates react with acids, reaction of acids and bases with each other, reaction of metallic oxides with acids, commonness among acid and base, importance of pH, more about salts, chemicals from common salt, are crystals of salts really dry? So coming to the introduction. Now in your previous classes that you have learned that the sour and bitter taste of food are due to acids and bases. If someone in the family is suffering from a problem of acidity after overeating, which of the following would you suggest as a remedy? Lemon juice, vinegar, or baking soda solution? Now, which property did you think of while choosing the remedy? Surely you must have used your knowledge about the ability of acids and bases to nullify each other's effect. Recall how we tasted sour and bitter substances without testing them. Now you already know that acids are sour in taste and change the color of blue litmus to red, and bases are bitter and change the color of the red litmus to blue. Now litmus is a natural indicator, turmeric is another such indicator, and have you noticed that a stain of curry on a white cloth becomes reddish brown when soap, which is basic in nature, is scrubbed on it? It turns yellow again when the cloth is washed with plenty of water. Now you can also use synthetic indicators such as methyl orange and phenolphthalein to test for acids and bases. Now what we'll study in this chapter are the reactions of acids and bases, how long acids and bases cancel out each other's effect, and many more interesting things that we use and see in our day-to-day life. So, understanding the chemical properties of acids and bases. Now, consider the activity. Now, collect the following samples from the science laboratory like the hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide, and ammonium hydroxide. Now, put a drop of each of the above solutions on a watch glass and taste with a drop of the following indicators. Now, what change in color do you see with red litmus, blue litmus, phenolphthalein, and methyl orange solutions? For each of the solutions taken. Now, just try to do this test with your teacher's assistant and write down your results. Now, these indicators tell us whether a substance is acidic or basic change in color. These are substances whose order changes acidic or basic media, and these are called as olfactory indicators. Now, let us consider some of the indicators. Now, take some finely chopped onions in a plastic bag along with some strips of clean cloth. Tie up the plastic bag tightly and leave overnight in the fridge. The cloth strips can now be used to taste for acids and bases. Take 2 of these cloth strips and check their order. Keep them on a clean surface and put a few drops of dilute HCl solution on one strip and few drops of dilute NaOH solution on the other. Now rinse both cloth strips with water and again check their order. Note your observations. Now take some dilute vanilla essence and clove oil and check their order. Take some dilute HCl solution in one test tube and dilute NaOH solution in another. Add few drops of dilute vanilla essence to both test tubes and shake well. Check the order once again and record changes in order if any. Now taste the change in the order of clove oil with dilute HCl and dilute NaOH solutions and record your observation. Now, which of these vanilla, onion, and clove can be used as olfactory indicators on the basis of your observation. Now, there is one more activity which tells about how do acids and bases react with metals. Now, how do acids and bases react with metals? Now, this is the activity which should be done with teachers' assistants. Now, set the apparatus as shown in the figure. Take about 5 ml of dilute sulfuric acid in a test tube and add few pieces of zinc granules to it. What do you observe on the surface of zinc granules? Past the gas being evolved through the soap solution. And why are the bubbles formed in the soap solution? Take a burning candle near a gas-filled bubble. Now what do you observe? Now repeat this activity with some of the acids like HCl and HNO3 and note that are the observation in all the cases are same or different. Now note that the metal in the above reaction displaces hydrogen from the acids. Now this is seen as the hydrogen gas and the metal combines with the remaining part of the acid and forms a compound which is called as salt. So how do metal carbonates and metal hydrocarbonates react with acids? Now consider an activity that take two test tubes, label them as A and B. Take about 0.5 gram of sodium carbonate in test tube A and about 0.5 gram of sodium hydrogen carbonate in test tube B. Add about 2 ml of dilute HCl to both the acids. Now what do you observe? Pass the gas produced in each case through lime water as you can see in the figure and record your observations. Now the passing of hydrogen gas evolved through the lime water. Lime water gives out white precipitate and passing excess carbon dioxide it is soluble in water. So the limestone, chalk and marble are different forms of calcium carbonate. Metal carbonates and hydrogen carbonates react with acids to give a corresponding salt, carbon dioxide and water. Now, how do acids and bases react with each other? Consider the activity like take about 2 ml of dilute NaOH solution in the test tube and add 2 drops of phenolphthalein solution. Now what is the color of the solution? Add dilute HCl solution to the above solution drop by drop. Now, is there any color change for the reaction mixture? Why did the color of phenolphthalein change after addition of an acid? Now add a few drops of NaOH to the above mixture. Does the pink color of phenolphthalein reappear? Why do you think that this has happened? Now, in the activity, we have observed that the effect of a base is fulfilled by an acid. So the reaction between an acid and a base to give a salt and water is known as neutralization reaction. So it gives out base plus acid gives out salt and water. Now reaction of metallic oxides with acids. Now consider the activity where you take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. Note the color of the solution. What has happened to the copper oxide? You will notice that the color of the solution becomes blue-green and the copper oxide dissolves. The blue-green color of the solution is to the formation of copper chloride in the reaction. And the reaction is given as metal oxide plus acid gives out salt plus water. Now reaction of a non-metallic oxide with base. Now you saw the reaction between carbon dioxide and calcium hydroxide. Calcium hydroxide, which is a base, reacts with carbon dioxide to produce salt and water. Similarly, the reaction between a base and acid conclude that non-metallic oxides are acidic in nature. Now, what do all acids and all bases have in common? Now, we have seen that all acids have similar chemical properties. What leads to the similarity in properties? Now, all acids generate hydrogen gas on reacting with metals. We have already seen in the previous activity. So, consider here one more activity where you take solution of glucose, alcohol, hydrochloric acid and sulfuric acid. Fix 2 nails on a cork and place the cork in 100 ml of beaker. Connect the nails to the two terminals of a 6-volt battery through a bulb and switch as you can see in the figure. And now pour some dilute HCl in a beaker and switch on the current. Now repeat with dilute sulfuric acid. Now what do you observe? Repeat the experiment separately with glucose and alcohol solutions. Now again take your observation. Does the bulb glow in all cases? The bulb will start glowing in the case of acids, as you can see from the figure, but you will observe that glucose and alcohol solutions do not conduct electricity. Glowing of bulb indicates that there is a flow of electric current through the solution. The electric current is carried through the solution by ions. Since the cation present in acids is H+, this suggests that acid produces hydrogen ions in solutions which are responsible for their acidic property. So, repeat the same activity using alkalis such as sodium hydroxide and calcium hydroxide. Now what you will conclude from these? Now what happens to an acid or base in water solution? Do acid produce ions only in aqueous solution? Now consider the activity where you take about 1 gram of solid NaCl in a clean and dry test tube and set up the apparatus as you can see from the figure. Add some concentrated sulfuric acid to the test tube. Now what do you observe? Is there a gas coming out of the delivery tube? These test the gas evolved successively with dry and wet blue litmus paper. In which case does the litmus paper change color? On the basis of activity, what do you infer about the acidic character of dry HCl gas and HCl solution? Now the experiment suggests that hydrogen ions in HCl are produced in the presence of water, and the separation of H+ ions from HCl cannot occur in the absence of water. Hydrogen ions cannot exist alone, but they exist after combining with water molecules, and so hydrogen ion must always be shown as aqueous or hydronium ion. Now we have seen that acid gives aqueous ion in water. Now what happens when a base is dissolved in water? Bases generate hydroxide ions in water, and bases which are solutions in water are called alkalis. Now, as we have identified that all acids generate H+ ions and bases OH ions, neutralization reaction gives out as acid plus base gives out salt plus water. Now, consider an activity where you take 10 ml of water in a beaker. Add few drops of concentrated H2SO4 to it and swirl the beaker slowly. Now test the base of the beaker. Is there a change in temperature? Is this an exothermic or endothermic process? Now repeat the activity with sodium hydroxide pellets and record your observation. The process of dissolving an acid or a base in water is a highly exothermic one. Now care must be taken while mixing concentrated nitric acid or sulfuric acid with water. Acid must always be added slowly to water with constant stirring. If water is added to a concentrated acid, the heat generated may cause the mixture to splash out and cause burn. The glass container may also break due to excessive local heating. Now look out for the warning sign in the figure on the can of concentrated sulfuric acid and on the bottle of sodium hydroxide pellets. Mixing an acid or base with water results in decrease in the concentration of ions per unit volume. So such a process called dilution, and the acid or base is said to be diluted. So this is about the acids and bases. We'll also continue with the chapter in our next video, and I hope you're enjoying the video. If you have any doubts, feel free to ask in the comment section below. Thank you for watching.